Good morning, students. Last class I was discussed some basic problems on arithmetic progression, and today I will continue the remaining questions. I think the question number 6 is completed in the exercise 9.2, and next 9.2 containing the question number 7 is find the sum to n terms. It means we want Sn value. Find the sum to n terms of arithmetic progression whose kth term is 5k plus 1 is given. It means kth term means here ak is equal to a plus k minus 1 into d. This term is called kth term. Is means equal to is 5k plus 1. It is the given condition. Then we have to find sum to n terms. Sn equal to how much? Here I will solve here. Solution. Here given term is what? Given term is kth term is 5k plus 1. It means I am taking here the kth term is ak. Suppose nth term is an. It is called nth term. And in case of n I am taking k means it is called kth term. Kth term. Therefore, ak is equal to the kth term is equal to kth term is what? 5k plus 1. It is equal to 5k plus 1. Already we know the term of an. An equal to a plus n minus 1 into d. It is the nth term order. Same way, kth term order is a plus k minus 1 into d. It is the general form. In place of a kth term is equal to a plus k minus 1 into d. Its value. It is general formula. And is equal to 5k plus 1, right as it is. Okay. Now, a as it is here k into d, common difference into k is k into d, and minus 1 into d, it is minus d is equal to 5k plus 1. Okay. Here all terms we don't know, first term as well as difference as well as k, we don't know value about its particular. Therefore, I am comparing here, comparing coefficient of k. We get see here the coefficient of k means I am comparing here kth term and RHS side kth term. What left remains here remain is d is equal to 5 left. It shows that d is equal to 5. So our common difference value is 5. And the remaining constant value, no unknown value, right as it is a remaining value. Except kth term, remaining value I am writing here a as it is, and minus d is the right minus d is equal to in RHS side 1 left, 1 as it is. And here a is equal to minus d goes to RHS side, it becomes 1 plus d is equal to 1 plus, what is the value of d here? D is 5. Take in place of d, it is a 5. So 1 plus 5 is 6. It means the first term value is 6 and common difference is 5. Then now we have to find the sum to n terms. It means Sn equal to, we find the value of Sn. I will write here. Now Sn is equal to n by 2, 2a plus n minus 1 into d is our sum formula. Here common difference is there 5 and first term is there 6. I will take here sum of n terms is equal to n by 2. We don't know n value, right, as it is, and 2 into the first term value a equal to 6 is there. I'm taking in place of a, it is 6 plus n minus 1 as it is, and the common difference value is 5 is there. Take 5 as it is. Here Sn is equal to n by 2 as it is. Here 2 into 6 is 12. Next, multiply 5 into n, 5n. Next, minus 1 into 5, it is minus 5. Now next, Sn is equal to n by 2. Here 12 minus 5. 12 minus 5 is 7. So I will write first nth term. Nth term is, it is 5n. 5n as it is. Here 12 minus 5 is plus 7. Actually, we don't know here number of terms. How many number of terms? That's why keep it as the result as it is. It is the our required result. Sum to n terms. Sum to n terms is n by 2, 5n plus 7 is the our required result. And next question number 7th is completed. Next is what? Question number, I think it is 8. Question number 8 is, if the sum of n terms of an AP, n terms of an arithmetic progression is Pn plus Qn square, where P and Q are constants. Then find the common difference. Find the common difference. Okay. Here I repeat once again. If the sum of the n terms of an AP, it means they are given sum of n terms means it is the value of Sn. They are given Sn is equal to, they are given condition Pn plus Qn square, where P and Q are some constants. Then find the common difference. Common difference means D is equal to how much? They are given Sn equal to Pn plus Qn square. Okay, so I will write given condition as it is. Here given is what? Sum of n terms. It means Sn is equal to they are given Pn plus Qn square. Pn plus Qn square. Okay, so we need to find common difference D. Okay, so Sn means already we know the general formula is Sn equal to n by 2a plus n minus 1 into D. Sn equal to, I am replacing Sn by its formula, is equal to, remaining term I will write as it is Pn plus Qn square. Okay, now multiply n by 2 to first term as well as second term. Here I am multiplying here n by 2 to first term, it becomes n by 2 into 2a. It is n by 2 into 2a plus I am multiplying n by 2 to second term. It means n into D by 2 of n minus 1. So n by 2 to first term, n by 2 to second term multiplication. is equal to, right, Pn plus Qn square as it is. Here 2 and 2 cancelled, remaining n into a, it is Na plus multiply n d by 2 into n. Here n into n is n square, and what remain d by 2? D by 2. First term n into d by 2 to first term n square d by 2, and n d by 2 into minus 1. It is minus n d by 2. Multiply n d by 2 to first and n d by 2 to second is equal to, here Pn plus Qn square as it is. Now we don't know here first term value as well as common difference value. We need to find common difference only. Therefore, I am comparing the power of n square and n square on both sides. We will get directly d value. It means common difference value. Therefore, comparing coefficient of n square on both sides. Compare both sides, n square term. Here I am comparing n square on LHS side and n square on RHS side. What left remain? Here n square coefficient is d by 2. I am writing here d by 2. Coefficient of n square. N square coefficient is here d by 2, written as it is, and equal to, here RHS side n square coefficient is q is there. So I am writing q as it is. Therefore, the common difference d is equal to, take 2 to RHS side, it is multiple of q. Therefore, 2q is the our common difference. Common difference d is equal to 2q. Hence, the common difference is what? 2q. And next question is question number 8 completed. Now I will solve one example question. After that, I will solve question number 9. Since both are same questions. The solved example, I think it is 6th one. Solved example 6th. I will write question here. Example number 6. The sum of n terms. The sum of n terms of two arithmetic progressions are in the ratio 3n plus 8 is to 7n plus 15. Okay, then find the ratio of their 12th terms. Before going to this solution, I will explain the sum terms. See here, the sum of n terms of two arithmetic progressions. Here they are given two arithmetic progressions. The first arithmetic progression Sn1, or you can take S first term is equal to A1 is the first term and D1 is the common difference. And similarly same Sn2 or second term is equal to A2 as first term and D2 as the common difference. Same, they are given here. Sn first term is equal to 3n plus 8 and Sn2 second term value is equal to 7n plus 15 in the ratio, and they are given sum to n terms of two arithmetic progressions values. Then we have to find the ratio of 12th terms. 12th term means we have to find a plus 12 minus 1. It is the value of n. It is 12th term means a 12th term is equal to a plus 12 minus 1 into d is equal to a plus 11 d. Its term is equal to, we want to find its ratio. So I am taking the given condition as it is. Here what they are given, sum of n terms of two arithmetic APs. Two arithmetic APs means I am considering, let a1 comma a2 be the two arithmetic first terms value, and d1 comma d2 be the two common difference value, be the two APs of first and common difference terms. That is what they are given, Sn of first term divided by Sn of second term is equal to, they are given 3n plus 8 divided by 7n plus 15. We want to find a1 plus 11 d1 divided by a2 plus 11 d2 is equal to how much? They are asking 12th term means 12 minus 1 means 11th term, 12 minus 1 means 11th term of both ratio equal to how much? So here Sn1 divided by Sn2 is equal to, I am writing as a term given. Here Sn1 means I am taking a1 plus Sn formula n by 2 2a1 plus n minus 1 into d1 divided by, here Sn2 second term means n by 2 2a2, before it is a1 it is the first term, it is a2 means it is the second term, plus n minus 1 into d2 means it is second term ratio, it is the first term ratio. Here a1 means first term ratio, a2 means second term ratio. Here I am taking first term as a1, here second term ratio it is a2, is equal to, right as it is, 3n plus 8 divided by 7n plus 15. Okay, here both n by 2 get cancelled, so remaining term I am taking here 2 as common. Inside the term it becomes a1 plus n minus 1 divided by 2 into d in the numerator, and same in the denominator I am taking 2 as common again. So a2 plus n minus 1 divided by 2 into, it is d1, it is d2 is equal to the nth term same, the given term right as it is, 3n plus 8 divided by 7n plus 15. Again here 2 get cancelled. Okay, here what they are asking means 12th term means, I will write on a note form the 12th term. Here 12th term is equal to a plus 12 minus 1 into d. It means 12th term means a 12th term is equal to a plus 11 into d. So compare these two terms, either you take numerator or denominator value. Here a plus n minus 1 by 2 into d is there here. Either take numerator nr value or dr value. So compare these two. Here common difference are same and first term are same. N minus 1 n minus 1 divided by 2 is equal to 11 is there. It means I am taking here n minus 1 divided by 2 is equal to, it is the 11 is there. It means n minus 1 to 2 goes to RHS side, it becomes multiple of 2, it becomes 22. It means minus 1 goes to RHS side, it is 22 plus 1. Therefore, n is equal to 23. We need to put here. You will get required terms. That's why I am taking n equal to, put n equal to 23. We get our required result. I repeat once again. Here a1 plus n minus 1 n minus 1 by 2 into d1. It is same as our general formula a plus n minus 1 into d. So here required result is 12th term, means compare this one. A 12th term equal to a plus n minus 1 into d. Here 12 minus 1 is 11. Here same in place of 11, it means nth term is here n minus 1 divided by 2 is there. Compare these two. N minus 1 divided by 2 is equal to what? 11. It means 2 goes to RHS side, it becomes 22. Minus 1 goes to RHS side, it becomes 22 plus 1 is 23. Therefore, we need to put n equal to 23 here. You will get our required ratio of 12th term. So that's why I am taking in place of n 23. Here a1, I am writing a1 as it is, plus here n minus 1 by 2, in place of n I am putting n equal to 23, minus 1 divided by 2 into d1 divided by, in the denominator a2, plus in place of n I am taking 23, minus 1 as it is, divided by 2, and d2 as it is, equal to in place of n and n I am taking 23. Here 3 into 23 plus 8 is there, 8 divided by 7. In place of n I am taking 23 plus 15. Here a1 plus, here 23 minus 1 is 22, 22 by 2 is 11 d1, and a2 plus 11 d2 is equal to, here 23 into 3, it is 69 plus 8 divided by, so here 23 into 7, it is 161 plus 15. Okay, now here a1 plus 11 d1 divided by a2 plus 11 d2. This means the ratio of first term of AP to ratio of second term AP. Here term is 12th term. The 12th term of first AP to 12th term of second AP ratio is equal to 69 plus 8, it is 77, and 161 plus 15 is 176. Divide here by 11. 11 into 7 is 77, and 11 into 16 is 176. It is equal to, here 11 7s are 11, 16s are it is. Therefore, it is equal to 7 by 6. Therefore, our required ratio is 7 is to 6. 16. 7 is to 16. So I am solving same type of questions in the exercise 9.2 containing, I think, question number 10. It is same like previous one. It means it is question number 10 shows that 18th term. Before this one shows that 12th term. Okay. Here I am solving same type of question. Question number exercise 9.2 containing question number 9. It is same like previous one. The sum of n terms of two arithmetic progressions are in the ratio here they are given ratio 5n plus 4 is to 9n plus 6. Okay, so same here, find the ratio of their 18th term. Previous one is 12th term. Here we want to find its 18th term. Here also I am repeating. Here they are given. It is the value of first term Sn1 term, and it is the value of Sn2 term, and we want to find a ratio of 18th term. 18th means a plus 18 minus 1 into d is equal to a plus 17 d. It means a1 plus d1 divided by a2 plus 17 d2 is equal to how much the ratio. Okay, so given condition I am writing same as it is. Solution, here also I am considering a1 a2 as the first terms of two arithmetic progressions, and d1 d2 are the first and common difference of two APs arithmetic progressions. Here what they are given ratio Sn1 is to Sn2 is 5n plus 4 is to 9n plus 6. It means I am taking here the sum of first term divided by sum of second term is equal to, here they are given 5n plus 4 divided by 9n plus 6 in the ratio. Okay, so Sn1 means here I am taking n by 2, 2a plus n minus 1, 2a1, here d1. First term as a1, common difference is d1 as first arithmetic progression divided by second arithmetic progression n by 2, 2a2 plus n minus 1 into d2. Here a1 d1 a2 d2 shows that first arithmetic progressions as well as second arithmetic progressions as the first term as the common difference is equal to 5n plus 4 divided by 9n plus 6. Here also n by 2 cancelled. So next term, first term containing 2 and second term containing 2 I am taking common, it becomes an easier one. So 2 I am taking outside common, it becomes a1, and second term there is no common term as 2, therefore it divides n minus 1 divided by 2 into d1 divided by, here in the denominator again I am taking 2 as the common, so a2 left. In the second term there is no 2, therefore it divides by 2 d2. Here both nr and dr containing I am taking 2 as the common is equal to 5n plus 4 divided by 9n plus 6, right as it is. Again here 2 cancelled. Okay, so now next putting the value of n. Here what they are given 18th term. 18th term means a 18th term is equal to a plus 18 minus 1 into d. It means a 18th term is equal to, it means 18th term is equal to a plus 18 minus 1 is 17 into d. Compare this term to either nr or dr, we get n value. What we put n value, we will get. Okay, here I am taking either NR or DR value 1. Suppose I am taking this NR A1 minus 1 by 2 into D 1. Here, first term same as first A as it is same and the common difference are same. But in place of n minus 1 by 2, it is 17 is there. So I am comparing these to n minus 1 by 2 place. N minus 1 by 2 place. It is 17. It is equal to 17 is there. Here, my 2 goes to RHS side. It becomes n minus 1 is equal to 34 and minus 1 goes to RHS side. N is equal to 34 plus 1. Therefore, n equal to 35. It shows that put n equal to 35, we get the ratios of our required terms, required 18th terms value. Therefore, I am putting here n equal to 35. Since compare this 18th term to our given condition, we will get n equal to 35. That's why I am putting n equal to 35 here. We will get the required ratio. Here, I am taking n equal to 35. Here, A1 I am writing as it is, plus, in place of n, I am taking 35 minus 1 by 2. 35 minus 1 by 2 into D1 divided by, here, in the DR denominator, A2 plus 35 minus 1 divided by 2 into D2 is equal to 5 into, in place of n I am taking 35 here, 5 into 35, 5 n is 35 plus 4 divided by 9 as it is. In place of n I am taking again 35 plus 6 is there, I am taking here 6. Okay, so here required result is what? 17th term. It means 18th term is 17D. Therefore, here A1 plus, here 35 minus 1 is 34 divided by 2 is 17 D1 divided by A2 as it is, and simplify this one. 35 minus 1 is 34 divided by 2 is 17 D2 into D2 as it is. So it is equal to, it means it is also a 18th term. It is 18th term of first and 18th term of second. These two indicates that the ratios between 18th terms values. Okay. So I will try to last on this one is equal to 35 into 5. Here I am multiplying 35 into 5. 5 into 5 is 25. 2 left, 5, 15, 175 it is, plus 4. It is 179. Here 35 into 5 is 175 plus 4 divided by, here 35 into 9. 35 into 9. It is 45. 4 left. 9 into 3 is 27. 27 it is 315. It is 315 plus 6. It means, so A1 plus 17 D1 divided by A2 plus 17 D2 is equal to, it is 179 divided by 321. 15 plus 6 is 321. 315 plus 6 is 321. And 175 plus 4 is 179. And these two terms is non-divisible numbers. Okay. Or you can write a 18th term of first AP. Otherwise, you can write in the ratio. Therefore, our required ratio is, our required ratio is 179 is to 321. Is the our required ratio. These two example and questions are same. We move for next question. Here, next question number 9.2 containing question number it is 10. If the sum of the pth terms of an AB of an arithmetic progression is equal to the sum of the qth terms of an AP arithmetic progression. Okay, so then find the sum of first p plus qth terms. I repeat once again. Here what they are given, sum of pth term of an AP is equal to sum of qth term of an AP. It means these two are equal. They are given the condition S pth term is equal to S qth term. Sum of pth term is equal to sum of qth term. Then find the SP plus qth term is equal to how much? They are asking, the question is find the sum of the first p plus qth term equal to. Okay, so I am writing the given condition here. SP plus qth term equal to question mark. Given what they are given, sum of the pth term. It means sum of the means S of pth term. Sn in place of n I am taking p is equal to sum of the qth term is equal to qth term means SQ. Okay, here already we know the general formula Sn is equal to n by 2, 2a plus n minus 1 into d. Replace n by p and q, you will get the sum values. Here in place of n I am taking p, it becomes p by 2, 2a plus p minus 1 into d is equal to, here qth term, sum of qth term q by 2, 2a plus q minus 1 into d. Okay, here both side divided by 2 cancelled, and multiply p2 inside the bracket, p into 2a, it is 2ap. Next plus p into this bracket, here p into d is p into d, p minus 1 as it is equal to, in the RHS side multiply q into 2a, it becomes 2aq plus q into 2 second term is q minus 1 into d into q, it is q into d into q minus 1. What? Multiply p2 first term second term, and here q2 first term and second term. And next here 2ap as it is plus pd into first term multiplication as well as pd into second term multiplication. Here p into d into p, it is p into p is p square into d, and minus is there, minus into plus, it is minus 1 into p into d is p into d is equal to, here 2aq as it is plus here q d into q is q square d, and q into d to second term, it is minus q into d. Here I am taking all RHS terms to LHS side, it becomes 2ap, and this one plus 2aq is there, take LHS side, it becomes minus 2aq. Okay, next plus p square d is there, p square d I am writing as it is, and RHS side q square d take to LHS side, it becomes minus q square d. Okay, now next it is minus q into d is there, take RHS side, it becomes plus q into d, and it is a negative term as it is, right, negative. term P into D is equal to 0. What I done here, the RHS side all terms taken to LHS side, it becomes plus, becomes minus, and plus becomes minus, and a negative term becomes a positive. Here first two term contain, common is 2a, I am taking common. What remain? P minus Q, and remaining all terms containing common is D. Common difference is the common. Therefore, I am writing here D as the common term. Remain P square left, here minus Q square left, plus here D taken as common Q left, and here D taken as common minus P left is equal to 0. Okay. Here I am writing D taken as a common. Here 2a P minus Q written as it is, plus common difference B also written as it is. Here it is the type of A square minus B square. Here A square minus B square formula is A minus B into A plus B. Same like here, A square minus B square. It is like A minus B. It means P minus Q into P plus Q. It is equal to P square minus Q square. And here P minus Q is there, and here also P minus Q is there. That's why I am taking these two terms containing negative as common. So plus becomes minus. I am taking negative to these two terms. Here minus P becomes plus P, and plus Q becomes minus Q is equal to 0. Here multiply minus into P, minus into minus plus Q. But I am taking negative since before term minus P minus Q is there, and here also P minus Q is there. That's why I am taking here negative as a common. Here 2a P minus Q as it is. Again these two terms containing, here first term containing P minus Q and second term is containing P minus Q. I am taking common. So remaining term is B of P minus Q. I am taking here common. The remaining term is P plus Q, and here minus 1 left, equal to 0. Again here P minus Q in the first term and P minus Q is the second term. I am taking common. Here P minus Q, I am taking these two terms containing P minus Q. I am taking common. Remain term is 2a left inside the bracket, plus again here P minus Q I am taking outside the common, D into P plus Q minus 1 left inside the bracket. Okay, here P minus Q goes to RHS side, it becomes 0, or you can take A into B. Either A equal to 0 means B is not equal to 0 type. Here I am taking P minus Q is not equal to 0 means second time is equal to 0. Otherwise, you can consider P minus Q goes to RHS side. It becomes multiple of 0. It is 0. Therefore, the remaining term is inside the term 2a plus D into P plus Q minus 1 is equal to 0, or D of P plus Q minus 1 is equal to 2a goes to RHS side, it becomes minus 2a. So give equation number 1. I am using this condition to find S P plus Q the term. It means the sum of P plus Q the term. Okay. So now they are asking sum of P plus Q the term is equal to. P plus Q the term is equal to. It means in place of N, I am taking P plus Q. Here N by 2. In place of N, I am taking P plus Q divided by 2. And inside 2A written as it is plus N minus 1. In place of N, I am taking again P plus Q. P plus Q minus 1, N minus 1 into D. In place of N, I am taking P plus Q. Here, yes, P plus Q is equal to P plus Q divided by 2 written as it is. And here 2 also I am writing as it is. But I am using equation value here. Here, D into P plus Q minus 1. These two terms are same. Then its value is what? Minus 2a. So I am replacing P plus Q minus 1 into D, and I will put minus 2a as the its value. Since by equation 1, I am using equation number 1. I repeat once again, P plus Q minus 1 into D. P plus Q minus 1 into D, its value is minus 2a. I am using P plus Q minus 1D as minus 2a. Here, 2a and minus 2a get cancelled. It becomes 0. So, 0 into any term is 0. Therefore, P plus Q divided by 2 into 0. Therefore, the sum of P plus Q the term is what? 0. Is our required result. See here, the question number 9 as well as the solved example 6 both are same. Here the question is the sum of n terms of two arithmetic progressions is they are given 5n plus 4 is to 9n plus 6. Then we have to find its 18th term is equal to how much in the ratio form. Here what they are given, sum of two arithmetic progressions is, it means it is the term of Sn1, it means the first term of AP, and the sum of it is the second term AP they are given. So it is in the ratio Sn 5n plus 4 is to 9n plus 6. So we need to find 18th term means A1 plus 18th minus 1, A plus 18th minus 1 into D divided by, it is considering as first term of AP and in the denominator considering as second term of AP into D2. It means it is A1 plus 17 D1 divided by A2 plus 17 D2 is equal to how much in the ratio. They are asking in the ratio form. Therefore, here I am taking these two given terms as Sn1 divided by Sn2 term is equal to, here they are given in the ratio of 5n plus 4 divided by 9n plus 6, and here Sn1 means the first sum of the first term of AP and Sn2 means the sum of the second term of AP. I am taking here first term means here first term A1 n minus 1 into D1 divided by, here I am taking Sn formula, n by 2 2a1 plus n minus 1 into D1 divided by n by 2 2a2 plus n minus 1 into D2. It is the sum of first term of AP, it is to sum of second term of AP is equal to, the given term is what, in the ratio of 5n plus 4 divided by 9n plus 6 is there. Here n by 2 are cancelled. Again I am taking 2 as the first term common and as well as second term containing 2 I am taking outside common. It becomes A1 left inside the bracket. Here there is no 2 term. That's why I am dividing here n minus 1 divided by 2 into D1. If you re-multiply it, it gives same result. Here 2 into A1 is 2A1 and 2 into n minus 1 D1 divided by 2 to get cancelled, you will get n minus 1 into D1 divided by, I am taking same 2 as the common, it becomes A2 plus n minus 1, there is no 2 here, that's why I am dividing 2, or otherwise divide nr and dr by 2, you will get same result into D2. Here 2 are get cancelled and in RHS side write as it is. Okay, so now put n equal to, the required term is what, 18th term we want to find. 18th term means I am writing here in place of n, it is n minus 1 term is there. A 18th term is equal to, A 18th term is equal to A plus 18 minus 1 into D is there. It means A 18th term is equal to A plus 18 minus 1 is 17 into D. Compare these two, either NR or DR, the term of n. So here nth term is n minus 1 divided by 2 is there. Here nth term is 17 is there. I am writing here either NR or DR to this side. It becomes A plus either A1 plus n minus 1 divided by 2 into D. Compare these two. The first term are same and common difference are same. It means in place of 17 it is n minus 1 divided by 2. It is equal to these both terms are equal. It means take 2 to RHS side. It is 17 into 2 is 34 and minus 1 goes to RHS side, it becomes 35. So we need to take n equal to 35. We get our required ratios. So that's why I'm taking n equal to 35. Here I'm taking n equal to 35. You will get a1 plus here 35 minus 1 divided by 2 into d1 divided by a2 plus 35 minus 1 divided by 2 into d2 is equal to here 5 into 35 plus 4 divided by, in place of n I am taking 35 into 6 here. It means I am writing here a1 as it is plus here 35 minus 1 is 34. 34 divided by 2 is 17. 17 d1 divided by a2 plus 17 d2 is equal to here 35 into 5 it is 161 plus it is 35 into 5. 35 into 5 it is 5 5s are 25, 2 left, it is 5 3s are 15, it is 17, 175 plus 4 and 35 into 9 is 321, 15 I think it is 315 plus 6. So 175 plus 4 is 179 divided by 321. These two are non-divisible numbers. That's why the required ratio is 179 is to 321.
Now, one of the student is asking, without taking n 2 common, we have to find out the n value for which term? 18th term of my son. Therefore, sum of the n terms equal to the 18th term. This, without taking 2 common, we have to multiply here 2. When comparing here a1 here to a1, here 17 d1. Therefore, here what you have to do to make the thing same when you are comparing 2a1 n minus 1 d1 2a2 n minus 1 d2. You multiply with numerator denominator with 2. 2a1 with 2 7 jar 14 34. Yes or no? D1. This will be 2a2 plus 34 d2. If you take common 2 here, we will get by 2. If you are not taking common, we have to adjust with 2a1, 2a1. Now we can compare them. Now by comparing the quotients, n minus 1 equals to 34. With this, n equals to, we will get 35. After getting 35, substituting here, we will get the value same. Multiplying with the 2 or taking 2 common. Both the ways you can do that.